we are talking about solving quadratic equations by completing the square. And in the case where there isn't a perfect square, we can make one. So complete the square. To complete the square for any quadratic expression of the form x squared plus bx. Now there's a couple things that we need to notice. Normally in standard form of the quadratic function, we have ax squared plus bx plus c. Now if we look at this form here, there's a few things that we notice. First of all, it tells us what our a value is. So for this example here, our a value has to be 1. Okay, the coefficient of the quadratic term must be 1 in order to complete the square. The other thing that we notice is right now in this example, we don't have a c value. It's just x squared plus bx. So the thing that we have to do is we have to create the c value that we want. So in order to find c, we just simply say c equals whatever our b coefficient is divided by 2 and square it. If we do that, that will give us the perfect c that will allow us to have a perfect square. Then you have to add the c value. So once you calculate the c value, then you have to add the c value. So we have a couple examples, and it says the first two, number 1 and number 2, we have find the c value that makes each trinomial a perfect square. Then write the trinomial as a perfect square. So the first thing we have to do here is we have to identify what all of our values are. So we notice that our a coefficient is 1, and our coefficient for our b value is 24. So b is equal to 24. And then we want to figure out what will be the c value that we can substitute in there that's going to make this trinomial allowed to be a perfect square when we factor it. So the formula from above to calculate c was c equals b divided by 2 squared. So we take whatever that b value is, we divide it by 2, and we square it. So we can just substitute the values in. In this case, we said our b value was 24. So everything else is going to stay the same. We're always going to divide by 2, and we're always going to square whatever's left. So we get 24 divided by 12, or 2 is 12. 12 squared is 144. So that is the c value that we're going to add, is going to be 144. So we can rewrite our trinomial. So we're going to say x squared plus 24x. And now we just calculated our c value, so we're going to replace that. Our c value is going to be plus 144. So that's our new trinomial that is going to allow this to be a perfect square. Now, if we factor it, the thing that we're going to notice right here, this value that we calculated, which was b divided by 2, that is going to be the value that we use to make our perfect square. So if we want to factor this trinomial, what are the only two values that multiply together to get to x squared? It's got to be x and x. This is the value that's going to allow this to be a perfect square. This value up here, we took the b value divided by 2, whatever that is, that goes in here. So x times x is x squared. 12 times 12 is 144. X times 12 plus x times 12 is 24x, so that gets us back to that trinomial. So we can rewrite this as x plus 12 squared. And then once we get to this point here, if we want to solve it, we can use the square root property to solve that, that equation or that expression. Got another example to look at here. And let's find out what our b value is. This one's not quite as nice because we have our b value is -5. So our b value is -5, but we still want to use that same equation there. I'm not going to rewrite this first part, but I'll just start right here. So we're going to say c is equal to, we're still going to divide by 2, and we're still going to square it. Now we just have to bring our b value down, which in this case is -5. Now, in this case, I'm not going to say, it's going to be more complicated to say -5 divided by 2 and then square it because it's going to give me a decimal. But if I distribute the 2 or the square to the denominator and the numerator, -5 squared is 25 and 2 squared is 4. So that is going to be the c value that we have to add in. So we have x squared minus 5x plus 25 over 4, and that is our trinomial. That is a perfect square. Now we want to write this in the factored form. Remember, the factored form is just whatever that value is going to be squared, that goes in there. And it looks a little complicated because it's a fraction, but that's the value that's going to make this a perfect square. So only two values that we can multiply together to get to x squared is x, or rx in x. Now, the value that we're going to square right here, that is the value that goes in to make the factored form, which in this case is -5 over 2. So -5 over 2, -5 over 2. And we can go ahead and check it again. 5 times 5 is 25. 2 times 2 is 4. X times x is x squared. And -2.5 plus -2.5 is -5. So that checks out. And now we can rewrite this as x minus 5 over 2 quantity squared, because we have two binomials joined by multiplication, so we can write it as one binomial squared. This last one, we're going to be able to actually go ahead and solve this one all the way through. And because we have a value here of 0, these other expressions, we didn't have an answer to check, but this one we can. Same process. All right, pretty close to the same process. The difference between these two and this one is this one there's a c value. And remember, we don't want to have a c value. We want to get rid of that c value. So the first thing we want to do is we want to add 3 to both sides. Add 3 to both sides of the equation because we want to get rid of this c value. So when we do that, we get x squared plus 6x. We need to find what our c value is going to be. So I'm going to just leave a space there because we're going to need to eventually calculate what our c value is. And that's going to be equal to, we have that positive 3 that we put over here. And then we're going to have to add, to keep our equation balanced, we're going to have to add that later, and we'll talk about that in a minute. So What is our b value? Right now, our b value is equal to 6. So we go back and use our equation. Go back and use our equation. So C is equal to the things that aren't going to change. We're still going to divide by 2, and we're still going to square. And we'll put our substitute in our b value. 2 divided by 3, or 6 divided by 2 is 3, and 3 squared is equal to 9. So we still need, the equation means that both sides of the equation need to remain balanced. And so we want to make this left side a perfect square. And the thing that's going to make this a perfect square is if we add 9. Well, if we add 9 to the right side of the equation in order to make sure that this equation stays balanced, we have to also add 9. If we add 9 to the left, we also have to add 9 to the right. So we have all the parts of our equation. Now we want to factor the trinomial on the left-hand side. And so we got to get 2 binomials. Only 2 numbers that multiply together to get to x squared are x and x. And remember, whatever is this squared value here, that is the thing that's going to make the perfect square for our binomials. So I'm going to add 3 and add 3. Now, on the right-hand side, we have 3 plus 9. That's equal to 12. Now we have x plus 3 times x plus 3. Anytime we have 2 of the same thing multiplied together, we can write that as something squared. So the binomial x plus 3 squared is equal to 12. And now we can solve this. We can solve this equation here. In order to get rid of the squared term, we need to take the square root of both sides of the equation. And then we get x plus 3 is equal to, now we took the square root in solving, so this has to be plus or minus the square root of 12. At this point, we're not going to reduce this. We're just going to leave it. We're not going to get it to a decimal. We want to leave it as an exact answer. And then we need to think about reducing our radical. So we can rewrite the square root of 12 as the square root of 4 times 3. Still keep that plus or minus out front. Now the square root of 4 is 2. So plus or minus 2 times the square root of 3. So that's reducing that radical right there. So I'm going to rewrite it one more time. So the left side stays the same, x plus 3. The right side, we changed it from plus or minus the square root of 12 to plus or minus 2 times the square root of 3. Now, the last thing that we need to do is get x by itself. And we do that by subtracting 3 from both sides. So in this case, we cannot do this math here. We could change this to a decimal and eventually do it, but we want to leave it as an exact answer. So the 3's on the left cancel, and we're left with x equals, and then we have negative 3 plus or minus 2 times the square root of 3. And then that is our final answer for this problem.